All right, so pre-cal 35.4, number 19. And this talks about a Ferris wheel that has a radius of 10 meters. And you see the diagram here below. So the radius would be 10 meters from the center of the Ferris wheel. So Ferris wheel, you know, the big wheel with the buckets there. You sit in a bucket and, you know, bucket. I don't know what you call that. But anyways, Ferris wheel, everybody knows what Ferris wheel is, I guess. So 10 meters. So you can see, they've kind of given you a neat little diagram here in the textbook that from the middle, the midline, to the top, the maximum height of the Ferris wheel would be 10 meters. So that means, looks like that A equals 10, because we're going to come up with an equation. See, A says write an equation to model this path. So they do a good job of here of showing, hey, time is passing on the x-axis here, and the lowest point would be right here on your graph. Here's the highest point, and of course this is going to be a range of 20 meters, isn't it? It's going to be a range of 20 meters. So passengers, first of all, it says it rotates once every 60 seconds. I see. So once every 60 seconds means from beginning of the cycle to the beginning of the next cycle, or to the end, is 60 seconds. So that is the period length. So period length is 60. Well, that's really helpful because we can now determine what B value is, right? So 60 is 2 pi over B, or B is 2 pi over 60, which B is then pi over 30. Okay, so A is 10, B is pi over 30. Passengers get on board at a point 2 meters above the ground. So going back to our little diagram here, this is 2 meters. That's the lowest point of the Ferris wheel, is 2 meters. So if I have 2 meters here, then this maximum point is 2 plus 20 is, looks like 22, right? So on your little diagram, the maximum point should be right here, should be 22. Oh, really? Don't like that. And 2 and 22. Oh, okay. A sketch for the first 150 seconds is shown. Okay. So 60 seconds. So we've got here's 60, here's 120, and then here's 150. Okay. So write an equation to model the path of the passenger on the Ferris wheel. So going back to my computer again here, pi over 30. So going back to the maximum and minimum value, I guess we can find out how this function, it looks like a cosine function. I'd kind of tend to write a cosine function that's maybe been flipped, right? Cosine normally starts at 1, goes down to -1, goes back up to +1. This one looks like it's flipped, so I'm thinking A maybe is going to be negative. But it's also been moved up. It's been moved up to, here's the midline. So 2 plus 10 should be a midline of 12 here. Okay, so if you think about the cos graph, and we'll make this a negative A value, so that's a negative 10, then the D value, so D should be moved up from a center line that was x equals or y equals 0. It's got to go up to y equals 12, so D should be maybe plus 12. And we don't have to move the cosine left or right, so it looks like we don't need a C value. C value can just be 0. Okay, make some space here. So let's try and write this equation then. It looks like we have y equals, I'm going to make this a -10 to flip the cos around, and 10 would be the amplitude, the radius, the amplitude. So I'm going to make this a cos graph. Does it say I have to use cos or to sine? No. So you get to choose to use cos. Now b is pi over 30. That's what's multiplied by the variable. So pi over 30. What do you want to use as the variable? T maybe for time. It's time here. So you want to use t? Let's use t. It's a good one. And y could be something other than y. It could be height maybe. Height, yeah, height is a function of time. Let's change that y to h, just a more appropriate variable, I guess. And we have to add 12 on the back end here. Correct? Okay, so here's our equation then. I'll just kind of move that up so we can see that at the top here. Am I frozen still? Thanks. All right, so I think that's A right there. H equals negative 10 cos pi over 30t plus 12. H is height, T is time in seconds. If Emily's at the bottom of the Ferris wheel when it begins to move, determine her height above the ground to the nearest tenth of a meter when the wheel has been in motion for 2.3 minutes. Okay. Obviously, T is in seconds, so 2.3 minutes, that would be 2.3 times 60. Okay, so 2.3 times 60. That's going to be 120 seconds plus another 20. So is that 140 seconds? Do that right in my head there. That's maybe not exact. Hang on. My bad. 2.3 times 60.
130.
What is it? Yeah, that's close. It's not exact. So, clear. So, I think so 138 is it? 2.3 times 60? Yeah. Okay. So 138, I guess 0.33 would be 120. All right, another 20, so 138. Okay, so so seconds. We don't want minutes, we want seconds. And if she started at the bottom, so I think we could just say, you know what, she's starting at the bottom here. That's where she's starting. And so 2.3 minutes would be exactly 138 seconds into the ride from 0. So we could use x equals, or t equals 138. All right. She doesn't get in at the top. Nobody gets in at the top. That would be a little bit of a waste, I guess. Can you imagine having all these, like, the spiral staircase way up here, and then you, like, get in at the top or something to climb up here and then jump in, so you go down. So we get in at the bottom. All right. Now, this the question says, determine her height above the ground to the nearest tenth of a meter. So whatever we determine the height above, that's going to be the height above the ground, because we've already calculated she gets in at 2 meters. Yeah, so if you're just going to use your scientific calculator, just do negative 10 times, and now cos, should this cos be in, should your calculator be in degrees or radians? Radians, yeah, it should always be in radians. So we just did a question that we had to move it to degrees, so yeah, do radians. And so 10 times, let's do cos. I'll use careful with the brackets here. Pi divided by 30 times t. So I got a couple sets of brackets there. Now your t is your x, right, on the calculator. And then plus 12. Oh, sorry. I'm sorry. Got to fill in x to be 138, right? 1, 3, 8. Good, and that should give us our value. So 15.09, you get that? 15.1. Anybody get that for an answer? Let's check. Yeah, 15.1 meters is our height. 0.09 or 0.1 meters. Okay, it's A and B there. So here's A. Any questions about that? With your graphing calculator, how could you do that? With the graphing calculator, you could put in your equation here, this one right here, and then you could put in another equation, y equals 15, or sorry, y equal, no, you just find a value 138 and it'll show you the point on the graph. If you had a question like how long into the ride was Emily first at a height of 17 meters or 10 meters or whatever. So basically they're giving you this right here. Here's the point. They want to find out what the time is. That's when you'd have to draw a secondary function of y equals, let's say 10 meters, y equals 10. And then you'd have to find the x value of the intersection point. Okay? So if they asked you for a time given a height, you'd have to do two equations and find the intersection point right there. Okay? Was there more to this question?
This C.
There is a C. Okay. So what does C say? Is it-
Determine the amount of time that passes before a rider reaches a height of 18 meters for the first time.
Oh, excellent. Okay. Okay. So in C, which I don't have on here, it's a height of 18 meters. 18 meters? Okay. And what is the time when the rider first gets to 18 meters? Awesome. So that's exactly what I'm talking about. Let's do that one together then. Computer troubles. So 18 meters is going to be around here somewhere. So what is this, the value of this point, right? What's the x value of that point? So that's where we go ahead and type in our equation. So negative 10. It should be in radians. So cos pi divided by 30. Secondary brackets, sorry, x bracket plus 12. 10 cos pi over 30x plus 12. Okay, and then we can graph that. The graph might be a little wacko here. Yep. Okay, got to change the window. You're not seeing much of that, so window, we're going to have to change that. So let's go to x minimum. Well, I suppose it could be 0. No, let's make that like a negative 5. So, and then an x max, going to be maybe 150, I guess, 150 seconds. And y, let's go negative 1 to 25 or something. Let's see if we can see that graph there now. There we go. Looking pretty good. So again, C says 18 meters, right? So let's go to y equals, let's go down and make 18 meters another equation. And so a line at 18 meters should show up. And so it asks, at what time does Emily first reach this height? So we're looking for the value of this point. We're looking for the x value of this point. So we'll do our intersect. Number 5, and we can type in, well, we can type in something small for our, thank you, thanks very much. Oh, I guess it's just asking first curve, so first curve, second curve, yep. And then either use your cursor like this or just type in a number that you think is around the value and then hit enter. So at y equals 18, this point is at 21. So 21.14, 21.1 seconds. So for C, if y equals 18 meters, then t, or h I should say, then t equals 21.1493. 21.1 seconds. And that's what they're looking for C. Okay. And then if we just take a look at B again, you can just put in a value, x equals, and you could plug in that value of 138, I guess. Now, as long as this is going to be, yep, on the right graph. So 15.09, there you go. That's another way to get your height there, see? 15.09, 15.1. Okay, any questions about number 19? There are two answers for what? For what? For which one? For C? Okay, well, what does the question say again? Does it say when did she first reach that? When did she first reach it and when did she reach it a second time? Oh, okay. Yeah, so this one, on the graph, this would be 21.1 seconds is the first time. This would be the second time. So yeah, so if that's right, if that's what the question says, then we will have to find the second one.
60.
Can you add 60? Well, see, 60 seconds would be way over here. It would be this point that she's reaching that point ascending. It says just the second time she's at that height?
No, it's actually another time. It doesn't say
Just
second.
another time? Oh,
Yeah.
if it's just another time, yeah, you could add 60 then, because that is one complete cycle. Yeah, absolutely. So if it's the second time, if we have to find this point right here, that's the second time she reaches that height. So, yeah, but you're right. You could add 60 if you want. Yeah, so 81.1 would be an acceptable answer. Or I'll just finish this, find a intersection. So first, second curve, yes. So let's find a point that's over here. So we need to kind of hold the cursor down and put the cursor, blinking cursor, near the intersection point you want to find, and then just hit enter, and it'll tell you. So 38.85 seconds would be the next time she's at that height. Okay, yeah, any questions? Got it? Good job.